Hello, my name is John Thompson. I am the founder of Spring Framework Guru. In this little course here, we are going to show you some pretty interesting stuff around building images for Spring Boot. So we want to be able to build these Docker container images with our Spring Boot application. So I'm going to show you a number of steps. We'll start off with the very basics, taking a Docker build file and getting our Spring Boot deployable jar into that image and then running it. And then we'll progress and start showing you some of the build tools. But first we need to go through and make sure that your environment is properly set up, and then we'll get into actually working with the build file. In this video, we're going to talk about the requirements for your development environment for this course. So what we want to do is have an operating system that supports Java development, obviously. This is going to be all the major operating systems out there, Mac OS, Windows, or Linux. I'm saying you probably want at least 8 gig of memory. 16 would be a little more comfortable, a little faster, but you should be able to get by with just 8 gig. And we are going to be using Java 11 or higher. So everything's going to be developed under Java 11. But if you're on a higher version, you should be okay. If you are on a lower version, you may run into issues. So I do recommend, if you're lower than Java 11, to update to Java 11. And you do need to have the JDK installed specifically. Now the JRE, the Java runtime, you do need the JDK. As far as the flavor of the JDK, Oracle or OpenJDK should be just fine. And then we are going to be getting into Docker. You do want to have Docker engine installed, and I'm saying 20.10.0 or higher. That should be perfectly fine for this course. And then we are going to be building Java. We will be using Maven specifically, and you should have Maven 3.6.0 or higher, and ideally have that installed for command line use. That'll make your life a little bit easier. And if you have any doubts on that, you can read the official Maven, Apache Maven documentation. They do a pretty good job of explaining how to set that up for your specific environment. So you do want to take a moment to verify your environment, and this can be very simply to go verify that Java is installed, so Java version. Then we want to make sure that the JDK is also installed, so that's Java C version. That will tell us that the Java compiler is available on the command line. Maven, we can just do Maven -v. That will show us the Maven version installed. And then we can run a simple Docker command, make sure that the Docker engine is up and running, and that's simply Docker PS, and that'll show us any running containers. Now, I do use, for the source code examples, I do use IntelliJ Ultimate. This is going to be used throughout the course, but it is not a requirement. You do not need IntelliJ Ultimate to go along with code examples in this. I do develop everything to be IDE agnostic, meaning it doesn't matter what IDE or any IDE that you use. Maven is the build tool. We will have a Maven build file, and we'll be able to build a project using Maven. So if you're using STS, Eclipse, or NetBeans, or some other IDE, perfectly fine. As long as it supports Maven, you're good to go. And worst case, you can always use Maven from the command line to build through the example. So again, IntelliJ Ultimate is not required to complete the course. It's just my preference of the IDE to use. Now that your environment is properly set up and we got Docker up and running, everything's happy, we are going to go in and start working with a Spring Boot project. First, I'm going to show you a project that we will be working with in this course. This is a ready-made Spring Boot project. This course is not specifically on Spring Boot, assuming that you are a Spring developer, so we'll go through, got a little Spring Boot application that we can work with for the purposes of deploying with Docker. And then we will start looking at a basic Docker build file as to how we build up that Docker image. And we'll go through this step by step, taking from a Maven project that's producing the good old Spring Boot fat jar, and then getting that into a Docker image and running it inside of Docker. So we will cover that in this course step by step. In this video, we are going to do a code review of the Spring Boot application that we are going to be working with. On the screen here, you can see that I have an API definition. So the Spring Boot application that we are going to be working with in this course is a simple Spring MVC REST type application. Here I have a beer service, and you can see that we've implemented endpoints for list beers, crate beer, get beer by ID, update beer by ID, delete beer by ID, and then also get beer by UPC. So a variety of RESTful style operations that we can work with. This API documentation, I will leave a link to it in the course resources. And then the implementation that we are going to be working with in the course is here. It's under KBE REST Brewery. So this is a Spring Boot project that implements that RESTful API, and I will also leave a link to this in the course resources. Now, I do want to prefix this. The course is for people that already know how to develop Spring. So I'm not going to be teaching how to build a Spring REST API. That's well covered in other content I have, and a lot of other people cover that as well. So to proceed, you do need to understand fundamental Spring MVC, creating RESTful APIs. But I do want to go through and do a quick code review to get you oriented to the Spring Boot project that we are going to be working with in the course. I'm going to toggle over to IntelliJ where I have the project uploaded. So here I'm in IntelliJ. This is the checked out project from GitHub, and I want to do just a code review on this. So first, let's take a look at the dependencies. So here is the Maven POM. Let me scroll up to the top here. We are using Spring Boot version 2.4.5. That is the most recent version at the time of recording of Spring Boot. And you can see here in the properties, we are using Java 11. I am using MapStruct and Project Lombok on that. More on those in a little bit. I do want to look at the Spring dependencies. We are bringing in Spring Starter for Actuator. Web, that is going to be Web MVC, not Web Flux. We have the starter for Spring Data JPA, so that's going to bring in data, or JPA and Hibernate. That's the ORM that we will be using. And then we are explicitly bringing in validation. There was a recent change to Spring Boot where the starter validation was previously included in Web within, I forget the exact version, within the last year or so. That is no longer included, so you do have to bring those in. And if you forget, this is one of those things that might fail silently where the validation is not getting picked up. That can be a problem because you forget that and then your validation silently fails to work. Then you can see on line 50, we are bringing in H2. We will be utilizing the H2 in-memory database, dev tools. Can we see Project Lombok, MapStruct, and then our test dependencies. Here, let's go up to the build plugins. We do have the Spring Boot Maven plugin. Because I am using a different version of Lombok than what's being curated, I am excluding that from the Maven plugin, so that doesn't get automatically built in. And here's an important part. If you're not familiar with MapStruct and Project Lombok, you do need to configure Maven like this to add in these annotation processors. I can't remember if the sequence is important, but it's important to have these annotation processors there. I would recommend try keeping the same sequence here because I know this works. If you have a different sequence, I don't know if that will work. And then finally on line 115, I want to point out this is a compiler argument, and this is what tells MapStruct to annotate the generated mappers with a Spring component annotation so that those mappers get brought in as Spring Boot components and we can do dependency injection on them. Without that, the project will fail to work properly. So let's come in here. I do want to take a look at the beer loader under Bootstrap. So this is going to be implementing the Spring Boot command line runner. What this does, it initializes our H2 in-memory database with 30 different beer objects. So you scroll down, you can see the various beers that I am loading up into the database. It just gives us some data, so every time we bring up the application, they get initialized into the database. Speaking of the database, we are using traditional JPA here. I'm not going to be covering JPA specifically, but you can go through, we can see that we are using Project Lombok annotations for data. Also, the builder pattern is being implemented, as well as a variety of JPA annotations for the UID and whatnot. This is what's getting persisted to the database. Now, we do have here, we are using a DTO model, so I do have MapStruct mappers defined to convert from the database entity to a DTO. So the DTOs are kept under the model directly, and all that works pretty well. Coming from the ground up, we are using Spring Data JPA repositories. We are following the repository pattern, so we do have a repository defined that is utilized in our services. So we do have an interface that we are coding to that does the basic CRUD operations for us. And then here you can see the actual implementation of the service. Let me close down some of these packages real quick. And then finally, we do have a Spring MVC controller. So this is what's going to be handling the web request. That takes in an instance of the beer service to support the CRUD operations. And we can see that we are using basic Spring MVC mapping. So we have request mapping, the path, parameters are being set up, all that's being handled by Spring MVC. And then we are following through using our service. Our service is going to be handling that. The service takes care of working with the database and then using the mapstruct mappers to convert to and from the web-facing DTO objects. So let's go ahead and I'm going to run this application. From IntelliJ, if you're using that, you just come up and say run. Yep. Just going to do a stop and rerun there. Sorry, I had it running in the background already. And here you can see the basic initialization. And I do want to point out here you can see that there is a console output saying that we've initialized the database. So at this point, we are running on port 8080. You can see that a couple lines above. The API documentation, we could utilize that to use Postman or something and exercise those CRUD operations against port 8080 on localhost. So we'd have 30 beers loaded into the H2 in-memory database, and then those RESTful APIs are now exposed and working. And if you want to take a moment on your own and go through and utilize a tool like Postman or curl to exercise the API just to see those working, to prove that it does work at this point, go ahead. I encourage you to do so, but I'm not going to be covering that specifically in the course. You should be able to start the application at this point. What this will do is tell you that you checked it out, you have your environment set up properly, it is building, and it is coming up and functioning properly. Okay, in this video, I'm going to show you how to set up a very basic Dockerfile for our project. Now, one thing I like to do is as I work through these courses, if you're not familiar with taking any of my courses, I will create a new branch. So I'm going to come in here and add in a new branch. I'm just going to call this Docker base. So we were previously on the main branch. Now we are going to Docker base. And this gives you the ability to see exactly what was changed in this video. So I will be doing that for the remaining videos where I'm actually changing code, and you'll be getting a new branch. So you can do a compare of your code to a specific branch and see what was changed or what you're missing. So very handy tool to give you. So now I am on Docker base, and let's go ahead and set up a Dockerfile. Now, there's a couple different ways that you can approach this. I'm going to put things under the main folder for the Maven project structure. Some people, when they're doing projects, especially if they're using a build script, they'll put it in the Dockerfile into the root of the project, which is perfectly fine. That is a valid way of doing that. But here, I'm just going to show you a typical setup where I'm going to come in here and I'm going to say new package. I'm going to call this Docker base. And let's go ahead and create a new Dockerfile. And by convention, that is capitalized, so Dockerfile, all lowercase. And I will be adding that to the branch. And here, I'm going to show you just a very basic vanilla Dockerfile for running our Spring Boot application. So I'm going to say from open JDK. You can see I'm getting the autocomplete there from IntelliJ. I'm going to say JRE. And I want the slim build, so this is a more efficient. And to be honest, you see I'm getting code complete for Buster, Sid, and Stretch. I honestly don't know what those are, so I do know the slim build is a more efficient image. It doesn't have a lot of the tooling in there, so it's a very small, lightweight image for us to work with. It does have the JRE, the Java runtime, so we are going to be putting in a jar file, so that is already compiled, so we don't need the JDK. The JRE is much smaller, so we have a much smaller image that we're going to be working with. And here we want to set up some environment. I'm going to steal from my working file here to the clipboard. And I'm just going to paste this in from my clipboard. And here I'm setting an environment variable, Java ops, and I'm setting up some memory limits for the JVM. And then this security from memory that goes through and helps initialize the JVM quicker, improves the startup time by setting that. I'm going to say workdir application. Now the trick is we need to copy into our file. So we're going to be copying into the image that we're building in our Docker build script. And what we want to do is, we don't have it here yet. So if you don't see it, we want to run the package command. So in the lifecycle, we want to run package or verify, either one of those, or install. But package is the minimal one that we need. So I'm going to go ahead and package that so that we do, in fact, get the jar built. And that does run our test as well. So we only have, I think, one test out there that brings up the context of a pretty lightweight project. Oh, so we actually have 4 tests. I misspoke. So now what we want to do is copy. And this copy command is going to be relative to the location of the Dockerfile. So we need to go up a couple directories. And then we want to say, should be getting a target. It's not seeing it as a project file. And I see what I made a mistake. I actually put this here. I want that under main. Let me do that quick refactor. So we have that under main. I mistakenly put it under Java, which is our class files. So we did not want that there. Now we're getting target in the autocomplete. And we can see that we have these two. So the .original is the slim jar. We want the fat jar. So that is going to be the executable jar there. So we'll go ahead and take that. That tells us to copy it, and we are going to copy it into the work directory. So the / is saying copy it into the working directory of application, and then we want to do entry point. Now we're going to pass it a command line. So we're going to say Java, and here we want to give it the name of the jar. So this is a little lengthy and easy to mistype, so I'm going to copy that to the clipboard and we'll paste that in. So this is a very minimal Docker file for running the Spring Boot application. So at the top, we are saying the Docker image that we want to pull from, the JRE Slim. We are setting environment variable for Java ops. We're just setting some memory limits, and then the security, that helps with our application startup time. We are telling it the working directory called application. We are copying from our local file system. So we are doing a relative path there to target to the generated jar file. We are copying that into our Docker image, and then we are setting the entry point, and this is the command that is going to be running on startup. So this is the Docker file. In the next video, I'll show you how we can run this from the command line. In the previous video, I showed you how to create this Docker file, and in this video, we'll show you how to actually build and run the image. Now, I'm going to be staying on the same branch here. You can see down on the bottom of the IDE, I'm still on the GitHub branch of Docker base. I'm only going to be doing demonstration here of the runtime application, and I'll be running this right from IntelliJ. IntelliJ does have a terminal that you can bring up, and let me clear that message. And here you can see that I am in the root of the project. Now, one very important thing here is the way Docker build command works. It will work from the current directory and down. So you can't go up. That is a security thing. And I actually found that out by the hard way. And it took me a little bit to figure that a little bit out. So here in the README, you can see that I've got a couple commands here. So I got Docker build -f. I'll be putting this in the README for your reference so that you'll have access to those commands. So here, let's go ahead and just make sure Docker is running. So if you do Docker PS, you can see that I do have a Postgres image running. That is perfectly fine. That won't bother us. So I'm going to do a Docker build Now for this to work, you can see that I have my target directory exploded and that the jar is there. So you do need to run Maven package before running this. Otherwise it will not work. So I'm going to docker build -f, and I'm going to say from here, go source, main, and I'm just hitting the tab key for the autocomplete. You can see the Dockerfile. So that -f tells the file that we want to build, and because I'm running from the root of the project, I'll be able to access that because you can see in the Dockerfile, remember I have that relative path, so I'm running from this point in the file system, so this will be able to traverse down and copy that file in. So if I ran from the Docker base folder, this would not be happy. So important aspect there. So that's setting the file, and then I want to do -t. I'm going to give this a tag, wrong window, and here I am going to do KBE rest, like so. Go ahead and tag that, and Docker build, and I see my mistake. I forgot to say current directory there at the end. So now we can see that we went out and we built it. It actually built fairly quick, and the first time you run it, I've already built a couple times, so the OpenJDK, that image is already there, so it's pretty lightweight for this to go ahead and build. So we're saying from, I didn't have to download that from the internet. The actual copy and stuff, that went fairly quick. Now let's go ahead and run that. You can see I set up the second man here for running it. So let me clear the screen. I can say docker run. And I'm just going to say -p 80, 80. That's going to map 80, 80 to the local host. And we'll do KBE rest. And I'm not going to use the -d flag. I put the -d flag there in the command because I want to go ahead and observe the startup log. So I'm just going to be starting this up. And we'll go ahead. You can see that I'm monitoring the logs, and that is now coming up. We can see that we have the normal Spring Boot startup. So now this application is up and running inside of a Docker context and a Docker image, and is running locally on my host. Port 8080 was exposed. So if I wanted to curl from a command line or use Postman or something, I would be able to exercise the API at this time. So I'm not going to be demonstrating that in this video. We can see that we are up and running, and I came up in the console mode interactively here, and to shut it down, I just do Control-C, and that will terminate the JVM. It goes away. If I do a Docker PS, you can see that now I have just Postgres running. And if I went to a second command line while that was running, the Docker PS would have shown that image up and running. Now, one thing that's very important about Docker and the way the Docker images work are layers, file system layers. As you get a lot of microservices out there, you want to be very aware of how the layers are working together and interacting together. A very nice feature of Spring that was introduced, I think it was in Spring Boot 2.3, if memory serves me correctly, is being able to do a layered approach. So we're going to break out our application into layers. So we'll have a layer for all those common dependencies, the stuff that doesn't change very much, and then another layer for our application, the stuff that does change. The stuff that doesn't change is going to be a big amount of data. Stuff that's changing in our application is going to be much smaller. So when we're doing deployments, the stuff that doesn't change doesn't get deployed again and again and again. Here, we are going to be much more efficient. So I'm going to show you how to use Spring Boot layers, how to configure our Docker build file to go ahead and utilize these layers. So this is a really important stuff, especially as we start getting into more production environments where we have applications that are being deployed and evolved and deployed again. So we're doing releases of those applications. This is going to make your life a lot easier, at least your DevOps guys, a lot easier as you move over to containerized environments. Okay, up on the screen you can see that I have Chrome up, and I am actually at my blog. So this is an article I wrote about a year ago on using Spring Boot layers. So this is a really cool feature available with Spring Boot. If you see the article here, I talk about how Docker itself works. So remember, as we build that image, we are going to be building layers in that image. So the JRE base image that we're using, that's going to have a collection of immutable file system layers. And I kind of think of these as effectively as a tarball with a hash. So every time you add something, it's a new tarball with a hash that is getting generated. So the Spring Boot layer is actually a fairly clever idea because if you, let's say you have a Docker host that has a bunch of microservices on it, and when you start getting into larger Spring or any Java application, when you start bringing in things like Hibernate and some of the more advanced type stuff, you get a large bundle of dependencies. So you can easily have a 200 meg image, but it's all jar files. And what happens is this big fat jar that you're stuffing into your Docker image, there's no way your application is only going to be a small, teeny part of that. And there's no way for the Docker build system to distinguish from that. So what this does is we build effectively multiple layers in that Spring application. So chances are, as you're doing some type of continuous deployment, your application is going to be changing. The Spring dependencies are going to be fairly stable. I mean, it depends on how often you are releasing or updating Spring. I know some organizations that they'll get out on a Spring version, and because it is so large across their applications, they might only upgrade once a year. So their Spring dependencies are going to be fairly stable for a year. So every deployment that they do, if they broke out to the layers, they wouldn't be redeploying those. So on the Docker host, once a layer is there, it's not going to get downloaded again. So if we break out all the Spring dependencies into its own layer, that layer will get reused over and over and over. When we do a new deployment with the application changes, and that is going to be just a small fraction of what's actually changing there. We put that into its own separate layer, then that application is only changing. So if you are running a larger system in production and doing continuous deployment, you can see how this is going to have significant savings coming up. So in this video, or in this section of the course, I'm going to show you how to enable it, give you a little preview. We are going to be adding in a Maven configuration. Then we are going to be adding in the dependency. So here you can see that we are setting up layers, and the way Spring did it, we have dependencies, Spring Boot loader, snapshot dependencies. So if you have any snapshot versions on dependent projects, those will get put in, and then your application. So chances are these two here, the top two folders, those layers will get converted into layers. Those will be pretty static as far as your deployments. And then the second two, the smaller dependencies, if you have any snapshot, personally, I don't think you should be deploying snapshot versions to anything, but that is just my opinion. And then you also have the application. That's where your Spring Boot application, the much smaller component, is going to be living. So we will be stepping through that. I'll show you how to set up the Spring Boot layer tools, as well as we will be doing a multi-stage Docker build. In this video, I want to toggle over to IntelliJ, and what we'll do is we will add in this little piece of configuration right here to our Spring Boot Maven plugin. And you do have to be on Spring Boot 2.3 or higher. This just came out about a year ago. So if you are on a previous version, that Spring Boot Maven plugin will not support this. I think you probably can add in that little bit of configuration, and it'll probably just ignore it. So, but then you might be mystified why it doesn't work. So I'm going to jump over to IntelliJ, and we'll go ahead and add that in. So I'm in IntelliJ. I'm going to go into the Maven POM, and I am on a branch called Layered Maven. And here you can see I have the Spring Boot Maven plugin, the excludes. I want to come up here. I just grabbed configuration and then layers. I copied that from my blog. So we are adding in configuration layer enable true. That is going to, by default, enable it. Default is not enabled. And then we are going to be including the layered tools, and that is going to come up into the build file. We will address the multi-stage build file in the next video. Okay, in this video, we're going to go ahead and configure the Dockerfile for a layered build. I'm going to collapse that down. And what I'm going to do is I'm going to create another folder called Docker. And this will come into play later on in this course where we'll be using a build tool with Maven to build Docker. So I'm just going to make that Docker, and we'll come in and add in a Docker file. Go ahead and add this to Git. And normally you wouldn't have two different folders for Docker. You'd only have one Docker file. But for the purposes of the course, I want you to be able to compare and contrast between having a slim, regular, traditional Docker file and then also the layered Docker file. So now we are actually building the layered Docker file. And what I want to do is I want to come in and this is going to be a multi-stage build, meaning that we will have two Docker images start up. So one will build, and we're going to be using that to run a command to extract out the layers. And then the second one is going to be the actual Docker file that we're using for our image. And we'll take the layers from the first one and copy those over. So let's take a little closer look as to what we're doing here. Again, we just need that. And we are going to call this as a builder. So that is, we're using this as a builder image. Again, work.dir is going to be application is just fine. And here I'm going to use the add command. Add and copy are very similar. And here I'm going to say target. We're going to get to the directory a little bit different. And again, we want to take that jar file. And that's going to be KBE. So that is going to add that in. And here what we want to do is say run Java -d jar mode equals tools. And I need to do / there. And if I mistyped something, we're going to copy it over. So we're going to say -jar. So this is a Java command. We are saying use the layer tools to extract out the layers. So that's all we want from this first builder. So inside this image, it's going to start up as a container. It's going to take in, it will add in that target, the jar file, and we are using the layer tools to extract out those layers. Now we're going to say from OpenJDK, we'll use the same one, JRE Slim. Again, we can use application, it's just fine. And now we're going to say copy. And actually, I'm going to copy this over from my working notes. It's going to speed up. I don't think you guys want to see me type all this out. So I'm going to cut and paste this in. So now you can see that we're saying copy from builder. So that's doing a reference to this image, saying from builder, from the directory application, dependencies, and we're going to bring those into our application. So this here is the first container that we're starting up, and then this is the image that we are building. And note here that we have the 4 layers that we are copying. So we have dependencies, Spring Bootloader, snapshot dependencies, which is typically going to be empty, then the application, and then the entry point. And the entry point, now we are going to use the Spring Boot Loader, the jar launcher. So slightly different. That's what allows all the class paths and stuff to get reassembled in this. And before we actually try to build this, remember here we added in that Maven configuration to do the layers. We want to do a clean on our project. Now we can say go ahead and do a package step. That'll package things up with the new layers being built. And while that's building, we want to do this. So I'm giving you that Docker command, and now it's not Docker base, it's just going to be Docker. And so it's the same command. So I'm going to copy that command and we'll take that into terminal. So now, rather than Docker base, we are going Docker, Dockerfile, and we'll tag that to KBE rest again. And you can see that we did have everything build properly. And you can see here that we are doing the multiple stages of the copy and then writing the image. And you can see that's coming up cache. That's because I ran it previously in my testing. If anything changed, it would have changed there. Just double checking everything. And now, if we do Docker PS, you can see that I still just have Postgres running. And let's do a inspect on this. We can do Docker history. And that'll be KBE rest. That is our tag. And here, what you can see, this is a history of that image. And these lines down here, that is all from the base image. So that is from the JRE image. So you can see that that's got a number of layers. Now we have a worker of application. And here you can see the actual dependency. So our dependencies, so that 41 meg, that's a good chunk of data. That is all our, that's the fat jar dependency, so all the various jars. And that's actually pretty slim for a Spring Boot project. So as you get into larger projects and having more complex applications, that can grow significantly. Then our Spring Boot loader, that is pretty light snapshots. And then there's our application. You can see that's only 90 kilobytes. So if we were deploying this, running multiple versions of our application, deploying that over and over and over, rather than having all this get copied into a single image, now these files here are going to be staying the same. They'll get reused. So if I have 4 applications running on the JRE, these are all going to get reused automatically because we're using that JRE image. If we have the exact same dependencies, these would get reused, and then only this one is going to be changing. So very, very important. This, if you start living with Docker on machines, you do realize that if you are tight on disk space, it can really chew up a lot of disk space. And this is a way to really make your disk utilization by Docker a lot more efficient. So this is going to be a lot more efficient for building and deploying applications in either a test or some type of production deployment environment. So the layers that the Spring Boot team came up with, it's a pretty clever way of saving yourself a lot of disk space and a lot of ongoing maintenance and having to go back and clean up the old layers that you may have on your system. Now, there's a number of different ways that we can actually build our Docker images. Maven is a very popular build tool for building your Java projects such as Spring Boot, so it's widely used in the enterprise. We can also leverage that in a Docker context as well. So we're going to go in and look at adding in a plugin to Maven to help automate our build. So if we are getting into a CI/CD type environment, having a common build tool capable of producing our artifacts, not only just the fat Spring Boot jar, but an actual Docker image directly from our build is going to become very important. In this section of the course, I'm going to show you exactly how to configure Maven to produce Docker images. So when it comes to working with Docker and building images from within a Docker context, you do have a number of different options. One very popular plugin for a long time was the Fabric 8 Maven plugin. You can see here that I have that on the screen, and it's been deprecated. And that just happened about 6 months ago. So I'm recording in May of 2021. So this is a fairly recent change at the time of recording that this was deprecated. Fabric 8 was a really cool project, but that project is no more. And so that plugin has been deprecated. It's been picked up by Eclipse, and it is now called JCube. So JCube is a very, very robust plugin. It was basically a branch of the Fabric 8 Maven plugin. This is where all the active development is happening. JCube works with not only Docker, but Kubernetes and OpenShift. It has a lot of very robust features. And I'm going to not use this one right now. Everything's very, very similar, but I'm going to be using a different Fabricate plugin called the Docker Maven plugin. And there's very easy to get confused as to which Fabricate Maven plugin we're talking about. The Docker Maven plugin, this at the time of recording is still active. It's still in the Fabricate repository. You can see here Fabricate.io, Docker Maven plugin. We're still getting commits. There was just a release done just a month or so ago, so on April 4th. This is still active. The core difference is this is a lighter, simpler plugin, and it only works with Docker. So only utilizes Docker. And you can see here we do have a number of options here. We can start, stop, build images. And you can see a number of things here. We can even watch for changes and automatically rebuild them. So there's a lot that we can do here. If you needed to run integration tests, bring up a container for an integration test, you could utilize this plugin. We are not going to be covering all the features here. We're primarily going to be looking at two pieces of this. To build images, we want to be able to automate our build process using Maven, and then push those images up to Docker. But I did want to take a moment, talk about this plugin, the capabilities of it. It does give you very nice integration between Maven and Docker. So we are interested in building Docker images. And what I'm going to do now is I'm going to toggle over to IntelliJ and show you how to start configuring this plugin for use in our project. So let me jump over to IntelliJ. And the first thing we want to do is come in and configure the plugin. So I'm going to put it in right here. So we want to do plugin, group ID. This is going to be IO Fabric 8. And it brought in the wrong one. So we actually want the Docker Maven plugin. And I'm going to go with 0.34.1. I think that is the current release. Let me double check that. I'm going to toggle over to Chrome real quick. It's actually 35, so we'll update this to 35. We get the very latest there. You can see that is red because I do not have that locally. So when I do a build action, this will be brought in. So I go ahead and I'm going to click on refresh to tell IntelliJ, and you can see that we're downloading that. Now I want to add in some configuration for this. The first thing we can do is we can do verbose. This will give us some additional information out to the console. Nice to see what's happening. And we can build one or more images. So there's a lot of things that you can do with this. We are going to use a Dockerfile build. You can actually use XML in the POM to declare your build. Here we are going to, I think it's simplest to use the Dockerfile, especially since we have a multi-stage Dockerfile here. We want that capabilities preserved. So we will go ahead and do that. And I'm going to say images, then image. We'll give this a name. I think we're calling it KBE rest, if I remember right. Now we need to declare a build element. And this is how we are actually going to be building our image. And what we need to do here is declare an assembly. And this works a lot like the Maven assembly plugin, at least according to the documentation. And we're adding in this line because what we want to do is it's going to be copying files around, and we'll take a look at that closer in the build process. So we're saying descriptor ref artifact. And by default, remember we set up the source main Dockerfile. By default, it's going to be looking in that. So we are going to say Dockerfile. And if I wanted to use a different file name, I could declare it like this, but I don't need to. And then we can also do a tag of our image. So let's do tags. We can do multiple tags. Here we'll just declare one for the time being. Call that latest. Now, one very important thing that we do need to change in our Dockerfile, this is going to be copying files around. And what we want to do is come to our Dockerfile, and rather than target, we want to tell it Maven. So now Fabricate, the Fabricate Maven plugin is going to be running the build. It's going to be running in that context, and the plugin is going to copy files, and we'll take a quick look at that. So come back over here. All that looks correct. I'm going to do a refresh here, make sure that we can see that. I'm going to disable our tests for right now, and we'll go ahead and do a clean. That deletes the target directory. We'll do a package. Let me resize some of these. You can see that our target directory is back. And typical build, this is the jar that we want to be including. So now I'm going to come over here under plugins. We can see Docker. And if I was running this from the command line, it'd be simply Maven Docker build. So I'm going to do the Docker build. And the way this is working, I'm doing it in sequence. If we were running from a command line and we didn't have the target directory created, we'd have to do Maven package Docker :build. So, but right now we've already done the package step. I'm going to go ahead and run the build step. You can see that the build did go and complete successfully. And let's take a closer look here. So now we see under target, we have a Docker KBE Rust, the name of our image. And then you can see here under build Maven, and that's why we had to set that there. So here we're running in this context. So now we need to tell it it's going to be running in the context of the build folder. That's where the Docker builder is going to be executing from. So that's why we need to change that Maven, because now our Dockerfile is now building from that location. So very important. So just to recap what we covered in this video, this is specifically the Fabricate Docker Maven plugin that we added, and IntelliJ hasn't picked that up yet, but I'll go ahead and correct that between the videos. And here the configuration, I did add in verbose to give us a little more chatter in the log so we can see the build steps happening. Otherwise, without the verbose, we wouldn't see the image being built like that. We are giving the image a name of KBE Rust. Basically, this assembly structure here, it tells the plugin to copy this Maven artifact over. So it says, hey, copy that into the build directory for us. We are specifying the Dockerfile to use. And by default, the plugin is going to be looking at source main Docker. And we're just saying the Dockerfile there. And we are applying one tag to the image that we're building of latest. And that will get tagged. You can see right here in the log output, tag with latest. And if we wanted to specify multiple tags, we could also do so here. Okay, currently we do have the image being built via Maven, but there's some things that we can do to make our life a little more easy as far as managing a project. And right now, if we take a look at the Dockerfile, we are utilizing the name of the artifact. So if we do a release, we change that version, what's going to have to happen is we are going to have to go in and update this. So if we did a release to 01 or 02, we'd have to go in and edit this file manually, and not something that we actually want to do. So what we can do is we can utilize Maven properties to control this. And rather than having the string here, we can have it replaced with a Maven property at runtime. So I come in here like so, and I do $, squiggly like that. Now I can say project.build.final name. And this is a Maven property that's available at runtime. This is the name of the jar. So when we run this, if we change the version, that is going to get changed. So I can just take that and copy him right to here, like so. So that takes care of our build file. So there's a couple other things that we can utilize this with also. So let's come back to our Maven configuration here in the POM. And one thing that we're doing here is we're setting it up as KBE Rust, and a different convention that I like to use. So remember the image coordinates, if we're pushing up to Docker Hub, are going to be our name. So in my case, I have a Docker Hub account called Spring Framework Guru. And then I want to give it a name. And the name I like to use here is from the project itself, the artifact ID. So the artifact ID, which is going to be the KBE Rust Brewery, that will get appended. So if I ever have to change the name here, that would change. I do like to have my repository reflecting that artifact ID name. Now my Docker image as well will reflect that. Then one additional thing that we can do here is we are tagging it. And let's say we're going through a release process or something like that. It'd be nice to have that version as well. So if I were to do a release to 01 or 02, we'd like to have a image with that. So what we can do here is, again, using a Maven property, we'll do project, and here we're just going to say project version, and that will pick up the version property. So now when this runs, we will get not only tagged to latest, but we'll also get the tag of version. And I don't have to rebuild everything, but I can come in here and run the build step and demonstrate this. So I'm just going to come in and do Docker build. And we'll go ahead and expand this window out a little bit. So we can see that the build did go through successfully and everything worked properly. You can see here, this line here, the property was properly applied at runtime, so that got replaced at runtime. So rather than having that property string, it did in fact work properly the way we expected to. So now if I change versions and doing a release or something like that, that will automatically happen. And then here we can see also in the log output that we have the tag of latest and also the 001-snapshot. So now we have that image with both tag of latest and snapshot. If I were to do a release, the tagged images will still be up in Docker Hub. The latest would get replaced, and then the 02 would be there, but 01 would still also be there. So this is a really handy way to version your images as you are doing releases with your Java projects. So let me minimize this and just recap exactly what I changed here. So I came into the Dockerfile, and for the file name, I'm now using a Maven property, so that will be picked up as the file name changes. When we change the versioning information, the file name will change, and now this will work properly at runtime when we're building a project. And then also in the POM, I changed the name of it, so I'm now adding in my Docker Hub directory, as well as I'm utilizing the artifact ID for the name. And then in our build, we are also tagging it with the current version of the build. Okay, in this video, we are going to be pushing images up to Docker Hub. So you can see I have Docker Hub up on the screen here. If you want to follow along, you are going to need your own Docker Hub account. They're free. It's free to register, free to use. So if you want to follow along, obviously you're going to need your own, because I'm not going to be sharing my credentials with the world here. So you can see here I have a number of different images that are already up there. In this case, we are going to be pushing this up there for the first time. Once you have your credentials, we do need to do a configuration step for the Maven plugin to pick things up. So here I have the plugin documentation from Fabricate, and we can see here that there are 6 different ways of defining the credentials. So you can do system properties, Docker username and password, registry username and password. You can do an auth config section in the plugin. Not too thrilled on that one, because right on the POM file you'd have credentials, so that's probably not a very good idea. You can use OpenShift configuration. A very common one is using the server tag in your Maven under your home directory .m2 settings. Set up a server, so server with Docker Hub, and then the credentials. So that's a pretty straightforward way of doing that. And then finally, you can do a registry. You can see here a credentials helper under a hidden folder in your called Docker config JSON. That one I have not seen used, but I'm sure it is used out there. So to follow along with this video, you will need to do both have a Docker Hub account and use one of these methods to set up the credentials. Once you do that, have that, you will be able to authenticate with Docker Hub, and you'll be able to push. So with that said, I'm going to come over to the command line now, or at least IntelliJ. And in IntelliJ, we do have the ability to bring up a terminal, which I'm going to do now. And what we can do here is say Maven Docker build. Docker push. So actually, if I was running this for the first time, if I wanted to run everything all together, I could do clean package Docker build Docker push. So that's going to run all those together. So let's go ahead and run that. And this is going to clean the project, rebuild it, run our couple tests there. You can see the Spring Boot dialog coming up. And in a second here, we'll get into the build phase. You can see here we are building the image. And here, this is actually the push up to the registry. So you can see Docker push. It is pushing up the various file layers that we created. And that last one's going to be a little big. Glad I have somewhat of a speedy internet connection here. And you can see here we have set everything up. So it has pushed up to Docker Hub now. We can see the hash digest here of what was pushed up. Let's toggle back over to Chrome and come back over here to Docker Hub and go ahead and do a refresh of that. And we can see here is the KBE REST brewery. It wasn't there previously. Somehow we got 3 downloads. I'm not sure how that happened. So, but we can see that this is now up inside of Docker Hub. We can see that we have the latest tag and also the snapshot as well. So that has now been pushed up to Docker Hub and is available for anybody that would like to use it.